What if I told you that inside a sphere the size of a basketball lies the firepower of a miniature sun? One spark, one chain reaction, and in less than a microsecond, entire cities simply cease to exist. Mushroom clouds climbing into the heavens. Shadows burned into walls where people once stood. An eerie silence where life once thrived. This is the story of the most powerful weapon humanity has ever unleashed upon itself. And by the end of this video, you will understand exactly how it all works. Welcome back to Spin of Facts, where we uncover the hidden mechanisms behind the things that shape our world, from the everyday to the absolutely extraordinary. I am your host, and today we're diving deep into one of the most complex and terrifying questions in human history. How do atomic bombs actually work? And how did we go from theoretical physics to weapons that could end civilization? If you love deep dives like this, make sure to hit that like button and subscribe. Imagine you light a match. One tiny flame, barely hot enough to boil water. Now imagine that same flame multiplied 1 billion times over, released in a single, catastrophic instant. That's the incomprehensible power we're talking about. But here's the question: how does such a weapon even exist? Our story begins not with explosions, but with equations. In 1905, a young patent clerk named Albert Einstein unlocked one of the universe's most profound secrets, EMC2. It looks simple, almost innocent. But this equation revealed something extraordinary. Matter and energy are two sides of the same cosmic coin. A single paperclip, if completely converted to energy, could power a city for hours. For decades, this remained theoretical. Until 1938, when German chemists Otto Hahn and Fritz Strassmann, working with physicist Lise Meitner, made a shocking discovery. When they bombarded uranium-235 with neutrons, something unprecedented happened. The uranium nucleus didn't just absorb the neutron, it split. It actually broke apart into two smaller elements, releasing enormous energy and, crucially, more neutrons. This process, called nuclear fission, was like finding the universe's ultimate domino effect. Each split atom could trigger more splits, creating what scientists called a chain reaction. Lise Meitner calculated that each fission released about 200 million electron volts of energy, millions of times more powerful than any chemical reaction. The atomic age had begun. It was August 1939. Europe was on the brink of war. In Princeton, New Jersey, the world's most famous physicist was signing what might be the most important letter in human history. Albert Einstein, alongside Hungarian physicist Leo Szilard, penned a letter to President Franklin D. Roosevelt. The message was stark and terrifying. Nazi Germany might be working on atomic weapons. If they succeeded first, they could become unstoppable. Roosevelt's response gave birth to the largest secret project in human history, the Manhattan Project. Within years, entire secret cities sprang up across America. Los Alamos in New Mexico became the brain center. Oak Ridge, Tennessee, became a massive uranium enrichment facility. Hanford, Washington, produced plutonium. At its peak, the Manhattan Project employed over 130,000 people. Most had no idea what they were actually building. Workers were told they were making parts for victory. Only a select few knew they were creating humanity's most destructive weapon. The project cost $2 billion, equivalent to about $30 billion today. Leading this scientific effort was J. Robert Oppenheimer, a brilliant theoretical physicist who would later be haunted by what he helped create. Under his leadership, some of history's greatest minds raced to turn theory into terrifying reality. Building an atomic bomb isn't just creating a big explosive. It's a precisely engineered machine that manipulates the fundamental forces of nature. First, you need the right fuel. Natural uranium is mostly uranium-238, which is relatively stable. But hidden within it is uranium-235, less than 1% of natural uranium, and this isotope is fissionable. The challenge? Separating U-235 from U-238. At Oak Ridge, scientists used massive facilities the size of buildings to separate these isotopes atom by atom. Alternatively, you could create plutonium-239 by bombarding uranium-238 with neutrons in nuclear reactors, as was happening at Hanford. Here's the crucial concept. Fissile material by itself isn't dangerous. A small piece of uranium-235 just sits there. But bring enough of it together, called critical mass, and the chain reaction becomes self-sustaining. For uranium-235, critical mass is about 52 kilograms, roughly the size of a softball. For plutonium-239, it's only about 10 kilograms, about the size of an orange. Scientists developed two different approaches. The gun-type design used in Hiroshima was relatively simple. Fire one piece of uranium into another at high speed using conventional explosives. When combined, they exceed critical mass, and boom. But plutonium required something far more sophisticated. The implosion-type design surrounded a plutonium core with precisely arranged conventional explosives. When detonated simultaneously, these explosives compressed the plutonium to incredible density, triggering fission. We're talking about precision, measured in microseconds. All explosive lenses had to detonate within a few millionths of a second of each other. When everything works perfectly, here's what happens in less than a microsecond. Neutrons strike uranium or plutonium nuclei. Those nuclei split, releasing energy and more neutrons. Those neutrons strike more nuclei, which split and release more neutrons. The reaction spreads exponentially. In just 80 generations of fission, which takes about a microsecond, a single neutron becomes over a billion neutrons, each carrying massive energy. The result? A fireball reaching temperatures of 100 million degrees Celsius, 6 times hotter than the center of the sun. Material vaporizes instantly. A shockwave travels faster than sound, and in seconds, you have a mushroom cloud climbing toward the heavens. July the 16th, 1945. 5:29 a.m., Alamogordo, New Mexico. In the pre-dawn darkness, scientists huddled in concrete bunkers 20 miles from ground zero. They were about to find out if 3 years of work and billions of dollars had created the ultimate weapon, or the ultimate failure. The device, nicknamed the Gadget, sat atop a 100-foot steel tower. At exactly 5:29:45 a.m., the first atomic bomb in human history detonated. Witnesses described a light brighter than the sun. The flash was visible 200 miles away.
J. Robert Oppenheimer, watching from his bunker, later recalled the Hindu scripture, the Bhagavad Gita. "Now I am become death, destroyer of worlds."
The explosion yielded the equivalent of 21,000 tons of TNT. The steel tower was completely vaporized. Sand in the desert was turned into green glass. A new mineral scientists named Trinitite.
August 6, 1945, 8:15 a.m. Hiroshima time. The Enola Gay, a B-29 superfortress, carried a single bomb in its belly.
Little boy, a uranium gun-type bomb, was about to demonstrate the terrible power of atomic weapons to the world. Below, Hiroshima was waking up, a city of 350,000 people going about their morning routines. Children walking to school, workers heading to factories, none knowing they were about to witness the dawn of the nuclear age. At exactly 8:15 a.m., Little Boy detonated 1,900 feet above the city center. In the first millisecond, a fireball formed, reaching temperatures of several million degrees. Everything within a half-mile radius was instantly vaporized. People, buildings, vehicles simply erased from existence. By the end of that day, an estimated 80,000 people were dead. By the end of the year, radiation sickness and injuries brought the death toll to over 140,000. But the horror wasn't over. 3 days later, on August 9th, Fat Man, the plutonium implosion bomb, was dropped on Nagasaki, Another 40,000 people died immediately. 5 days later, Emperor Hirohito announced Japan's surrender. World War II was over. But the nuclear age had begun, and the world would never be the same. Today, 9 nations possess nuclear weapons, with a combined total of approximately 13,000 nuclear warheads. That's enough firepower to destroy human civilization several times over. We now live in a world where the power to end civilization exists in the hands of 9 nations, stored in weapons systems that can deliver unimaginable destruction anywhere on Earth in less than an hour. It's a reality that's both a testament to human ingenuity and a reminder of our capacity for creating tools of ultimate destruction. So there you have it, terrifying science, the desperate race, and the world-changing moment when humanity unlocked the power of the atom. From Einstein's simple equation to mushroom clouds over Japan, we've journeyed through one of history's most profound and troubling achievements. Now I want to hear from you. Do you think nuclear weapons have prevented more wars than they've threatened? Or has humanity simply been incredibly lucky for the past 80 years? Drop your thoughts in the comments below. I read every single one. If this deep dive opened your eyes to something new, do me a favor, smash that like button. It really helps the channel grow. And if you're not already subscribed to Spin of Facts, hit that subscribe button and turn on notifications so you never miss our next exploration into the hidden mechanisms that shape our world.
Thanks for watching, and I'll see you in the next video, where we'll continue uncovering the extraordinary stories behind the things we often take for granted.